Hello friends and welcome to mathOgenius. I am here to help you with math. So, I am doing a series of videos in which I will solve questions on application of derivatives. I just gave a video on the basics of maxima and minima, and now I will solve the most important questions on maxima and minima like these. So, I figured it out that in maxima and minima there are very little types of questions. There are a lot of questions, but they come in a very little variety. Like some of them are box questions, some of them are inscriptions, etc, etc. So I figured out that there are 10 which are most important questions on maxima and minima, and if you know how to solve all those 10 questions, you can solve any question in maxima and minima if you know how to solve each of them. So in this video I will solve 5 of them, and one question I will give you for homework so that you can try this question. I will solve a same question like that in this video, so you can get help and do the same in this question and you will solve that question very easily. In the next video I will also give the solution for this question and other 4 with this one. Okay, so in this video I will solve all these questions. These are the 5 which are very important questions in maxima and minima. So let's begin. So this is our first question, so let's read the question very carefully. An open-topped box is to be constructed by removing equal squares from each corners. That means we have to remove these squares. I wrote 1 meter here to demonstrate that if we cut 1 meter squares of 3 meter by 8 meter rectangular sheet of aluminium, that means this sheet is 3 meter by 8 meter sheet of aluminium, but basically this is paper, and folding up the sides, that flap which will come, we will fold up them and we will create a box. Find the volume of largest such box. We have to find the volume of largest such box. We will use maxima minima to solve this question. So first let's demonstrate this on this sheet of paper. First we have to cut up the sides. So now we cut up the sides and we will fold up these flaps up. So to find out the maxima, we first need a function. So what will be the function? The function will be the volume of this box. So volume will be, what is the volume of cuboid? Yes, that is length into breadth into height. What will be the length? First the original length was 8 meter, but then we cut out 2 x's from this 8 meter, that we are cutting the x. We don't know that this is 1, 2, 3. I wrote it 1 to demonstrate that we are cutting 2 units from each side. So 8 minus 2x will be its length, its breadth will be 3 minus 2x, and height will be the x. So now let's solve this. That is 8x minus 2x square. First I multiplied these and then 3 minus 2x. So let's solve this. First multiply this and this. 8 is a 24x. Then this and this minus 16x square. Then this one minus 6x square. Then this that is plus minus minus plus 4x x square, x that is cube, and after this 4x cube minus 22x square, 16 6 22 x square plus 24x. So this is our function. So to first find out maxima and minima, what we do? We find out f dash x. And if you don't know what are those steps, first watch the video on the basics of maxima and minima. So now f dash x will be 4 3s are 12x square minus 44x plus 24. Now this was f dash x. Now the next step is that we find out x, and we are solving this via second order derivative. Yes, I told you in the basic that this is the most important thing, and in every question these steps are going to be applied. So let's find out x. To find x we have to put f dash x is equal to 0. So 12x square minus 44x plus 24 is equal to 0. Now we can take out 4 from this common and then we will divide it by 0 and it will go to 0. So 4 3s are 12 minus 11x plus 6 is equal to 0, and now we will take up 4 and it will become 0. So we got the equation 3x square minus 11x plus 6. So this was the equation. So now we have to find out x. So to find out x, we will use factorization method, that is 6 3s are 18 and the center is here 11. So we have to add two numbers in here which gives the multiplication of this and sum of this number, that is 3x square minus 9x minus 2x plus 6 is equal to 0. See this, 9 2s are 18 and the sum of this number is 11. This is a very simple factorization method. You should know this method before jumping into maxima and minima. So now let's take up common, that is 3x, x minus 3 and minus 2, x minus 3. You will be wondering how this minus sign came. This came like this. If we solve this, minus 2x and then plus 6 equal to 0, 3x minus 2, x minus 3, and we got x 2 by 3 and x is equal to 3. So x is equal to 3 we can't apply, because if we cut 3 from here we will cut its whole edge and we can't make a flap. So this is not possible. So we got the x is equal to 2 by 3. Now to find out that this value of x is maxima or minima, we first need to find out f double dash x. So f dash x was 12x square minus 44x plus 24. Now f double dash x is 24x minus 44. Now we will put the value of x in this question, that is 24 multiplied by 2 by 3 minus 44. Now let's solve this up, that is 48 by 3 minus 44 is equal to 48 minus 132 by 3. The answer is minus 84 by 3 and I think it is divisible by 3. There is a Vedic math tip that if you need to find out what is divisible or multiplicable by 3, you have to add those numbers, like 8 plus 4 is 12 and 12 is divisible by 3, so this number should also divisible by 3 and it is 28 in negative sign. This is less than 0. So this is less than 0, that means it is maxima. These are the basic, that if this is less than 0 it is maxima and if it is greater than 0 it is minima. So now the value of x is equal to 2 by 3 is maxima. So now we will chunk in the value of x in the original volume and we will find out the maximum volume of this such box. So let's find out the volume. First we have to write the volume was 4x cube minus 22x square plus 24x, and now we will put the value of x in this function, that is 4 by 2 by 3 cube minus 22 2 by 3 square plus 24 2 by 3. Now 4 into 8 by 27 minus 22 into 4 by 9 plus 24 into 2 by 3. So let's solve this up, that is 32 by 27 minus 88 by 9 plus 48 by 3. Now we will get the LCM of this, that is 27, 32 minus 9 3 is 27 and 88 multiplied by 3 is 264 plus 3 9 27, that is 9 multiplied by 48 is 432. Yes, 432, and now we will solve this up. That is 464 minus 264 by 27 is equal to 200 by 27 meter cube, and this is the maximum volume of largest such box. This question was very easy, it was easy to understand, and we just solved this question. Everything is calculation in this question. Your calculation should be perfect to solve this question. And I also want to share another Vedic math tip in here. If you want to multiply a 2-digit number by 11 like 24, you just have to do is this: 2, 4, 2 plus 4, 6. This is the answer for multiplication for 11. This is the Vedic math tip. I will share more Vedic math tips further in this videos. So let's move on to the next question, which is similar to this question. This is the second question. In this question, a square piece is taken. In the previous question, a rectangular piece was taken. This is the only difference between these two questions. The value are different, and every single step of this question will be same, just the calculation will be different. So I just took up that box in here, and here the sides will be same in this question. So let's solve this question up. So let's read the question very carefully. A square piece of tin of side 18 cm is to be made into a box without top by cutting a square from each corner and folding up the flaps to form a box. What should be the side of the square to be cut out so that the volume of box is maximum possible? In this question we have just asked how much side we have to cut to get the volume maximum possible. So let's write the volume of box. That will be x 18 minus 2x, that's height, length, breadth, which will be same as length because it is square. So now we will solve it. That is 18x minus 2x square and 18 minus 2x. Now we will further solve it like this. That is 3 to 4x minus 36x square minus 36x square plus 4x cube. Now further solving it, that is 4x cube minus 72x square plus 324x cube. And now after this we will solve it further. Now we have to find f dash x, which is 12x square minus 144x plus 324. Now to find the value of x, put it equal to 0. That is 12x square minus 144x plus 324 is equal to 0. Now after this 12 will come out common. That is 12x square minus 12x plus 27 is equal to 0. Now 12 will go that side and it will become 0, and we got x square minus 12x plus 27, that is equal to 0. Now we will use factorization method. That is, we need the multiplication 27 and addition 12, which we can get by 9th is a 27. That is x square minus 9x minus 3x plus 27 is equal to 0. Now after this x will come out common. X minus 9 minus 3 x minus 9 is equal to 0. We got x minus 9 and x minus 3, which is equal to 0. X is equal to 9 or 3. Now we can't accept 9 because if we cut 9 cm out of 18, it will get half and we will not get half of it, and we can't make a box with this thing. So 9 is negligible, and now we'll use 3. So the side cut out is equal to 3. Now we have to find f double dash x. So f dash x was this f double dash x, that is 24x minus 144. Now we will put the value of 3, that is 24 multiplied by 3 minus 144. Clearly it is getting negative, that is 72 and minus 144, and 72 minus 144 is minus 72. So this is less than 0, which means it is maxima. So the side of the square that is cut out is equal to x is equal to 3, which is our answer. So we have to cut out 3 centimeter from its side. So now you know the questions in which we have to cut out sides and make a box. So I will give you a homework of this question. You have to solve it by yourself. In the next video I will come up with the solution. So a rectangular sheet of tin 45 cm by 24 cm is to be made into a box without top by cutting off squares from each corners and folding up the flaps. What should be the side of the squares to be cut off so that the volume of box is maximum possible? So solve this question at home. If you don't get it right, no problem, I am coming with the solution, but I know that you will get it right because you have solved 2 questions similar like this. So pause this video now and note this question in your textbook. Okay, so if you have noted this question, let's jump into the next question. The next question is that show that all the rectangles inscribed in a given fixed circle, the squares have the maximum area. That means that if you have given a circle and if you inscribe rectangles in it, from all those rectangles, when it will become a square, it will have the maximum area. It is a question of maxima and minima, and these are the most famous inscription questions in maxima and minima. And these questions are asked like this, like if you inscribe a cube in a sphere and if you inscribe a cone in a rectangle and etc, which will have the maximum area, which will have the minimum area, like this. These are very important questions and they come in everywhere in this world. Okay, so let's find out the answer of this question. So in the last questions, that is like these questions, I differentiated with respect to x, that was the edge which was cutting. Like we know that differentiation is finding the change and we can only change the edge in that. In this we can't change the sides. Okay, this can grow small and this can grow this and this can grow this, but the circle is fixed. If this will decrease, this will increase, and then it will be the same. So we can't change the sides. The only thing that can change is the angle, that is the theta. So in this question we will differentiate with respect to theta. So first let's name this rectangle, that is A, B, C, B, D. So area, that is area of rectangle, area will be this multiplied by this, that is AB multiplied by AD. Okay, so now this is theta. We don't know the sides. The sides will change according to theta. They won't change, they will remain equal all the time, but they will grow and small and they will change according to theta. So we have to find the sides according to theta. So this is the base, these are the radius of circle. So when we have to find the sides according to the hypotenuse, we use trigonometric functions. Like when we have to find the base, we take up the, like you don't know, like you know that this is sine, cos, tan, cosecant, secant, cot. So in this we can take cos theta to find the base. Like base upon hypotenuse is equal to cos theta. Base is AD and hypotenuse is 2r, that is r plus r is cos theta. So AD is equal to 2r cos theta. This is the base, so this is 2r cos theta, And to find the perpendicular, always remember there is 90-degree sign between the rectangle and the square. So this is a right angle triangle, so that we can apply the trigonometric functions. So to find out the perpendicular, let's find the perpendicular. We can use sine theta, that is perpendicular upon hypotenuse. So the perpendicular is CD, hypotenuse is 2r, and sine theta, and this is also 2r sine theta. So this is 2r sine theta. So we found out this. Now we can put this in here, that is 2r cos theta multiply by 2r sine theta. I won't multiply the 2 because in the question that is 2.2r square cos theta sine theta. Do you know that trigonometric rule that 2 sine theta cos theta is equal to sine 2 theta? So 2r square, this 2 is used up in here, sine 2 theta. After this we will differentiate it with respect to theta, that is d by d theta is equal to 2r square sine 2 theta. Now differentiating with respect to theta, 2r square, sine's derivative is cos 2 theta, but this is 2 in here. You know the chain rule, you should know the chain rule before jumping into application of derivative, and we will get more 2 in here. So that is 4r square cos 2 theta. We got the 4r square cos 2 theta in here. Now we will find the theta with this. Put it equal to 0, then cos 2 theta is equal to 0. It came there and it became 0. And now cos 2 theta is equal to cos inverse 0. Cos inverse 0 is similar like cos 0, and the value of cos 0 is pi by 2, and the theta is equal to pi by 4. Now we have to know that is this maxima or minima. We will differentiate this again. Now we got the theta, that is pi by 4, and the derivative was 4x square cos 2 theta. Now we will differentiate it again. That is 4r square, cos derivative is minus sine 2 theta, and 2, and 8r square minus sine 2 theta. And it is clear from here, here is minus sign, and if we put pi by 4 in here, we will overall get negative, and this is less than 0. That means it is maxima. This value is maxima, so the area will be maximum, and the maximum area of that will be square, but we have to prove it for now. So what is the property of a square which is different from a rectangle? That is, it has same sides. So if we put theta in here in the both side, and if we got these two sides same, this means that we have square and it has the maximum area. So let's put it inside, that is AD is equal to 2r cos theta. Theta is pi by 4, and cos pi by 4 is equal to 1 upon under root 2. That is, if we further solve it, 2r, rationalize it, we get under root 2 by 2, and this is 2, this is r under root 2. This is AD, and now we have to find CD, that is CD is equal to 2r sine theta, and 2r sine theta is equal to pi by 4, and solving this up, that is 2r sine 1 upon under root 2. This value is same in both sine and cos. After solving it, we will further get r under root 2, which is equal to the length. So in this, length and breadth are equal, which means that is a square, and we have proved that the sides are equal. This means it is a square and it has maximum area. So in all the rectangles which are inscribed in given fixed circle, the square have the maximum area. So we solved this question. Now let's jump into the next question. Okay guys, so this is our next question. So let's read the question very carefully. Show that the semi-vertical angle of cone of maximum volume with given slant height is tan inverse under root 2. These type of question are the angle finding question, and these are also very common in competitive exams overall the world. So if you know how to solve this one, you can solve all of them, because this one contains everything you need to know how to solve all those questions like this. So increase your awareness, because these questions are also very important. So you are asked that show that the semi-vertical angle of cone of maximum volume with given slant height is tan inverse under 2. Semi-vertical angle is this. So we have to find that this is tan inverse under 2. When the volume of the cone is maximum, that means the volume is maximum, and you have given a slant height, that means this is constant. So now a question arises that in which respect we will differentiate this question, because in maximum minima you should know in which respect you are differentiating. So first we need to know what is changing, because differentiating is finding the change. So in this, height will change, this will remain constant, and theta will change. What we have to find? We have to find tan inverse under 2. What is this? It's an angle, but means theta. So now we know that we will differentiate with respect to theta. So first let's write what is the volume of cone. So what is the volume of cone? That is 1/3 pi r square h. This is the volume of cone. So now we will put in the values of r and h, but we don't have any values of r and h, and we have to find theta, and there is also no theta. So we will find r and h with respect to theta. So how will we find r and h? See this. This is a right angle triangle. So we can use trigonometric functions to find h and r. R is the radius of this cone. So now we will find h and r using trigonometric function. How you know this? I just taught this. Sine, cos, tan, cosecant, secant, cot. So now we will use trigonometric function to find out that this is with respect to L, because L is constant and we won't differentiate it. We will have theta, we will differentiate, and then we can find theta. So base will be, that is cos theta is equal to base upon hypotenuse, and cos theta is equal to base, which is h, and hypotenuse, which is L. So h is equal to L cos theta. So we got the height, which is L cos theta, and similarly if we have to find r, we will use sin theta, that is perpendicular upon hypotenuse, and then solving this further, perpendicular is r, h, L, r is equal to L sin theta. So we got these two values, but we have a constant which won't differentiate and a theta which is differentiable, and we can find the answer with this theta. So let's find the answer further. So let's chunk in these values, that is 1/3 pi r square. R is this, so L square sin square theta, and h is L cos theta. This is the answer. I got these squares because there is r square, and then 1/3 pi L cube sin square theta cos theta. So what we got? It's a function. Now we got a function for solving maxima and minima. Now first thing we have to do is differentiate, that is finding f dash x with respect to theta. So I am not differentiating with respect to L here. So f dash x with respect to theta, that is d by d theta. I wrote it like this, and now L cube pi by 3, that is when constant and function is here, differentiation is constant times the function. So like this is all constant and we will chunk in here, and this is the function and we will differentiate it. And so first function, this is a product rule. First function, second function. First function differentiation of second function plus second function differentiation of first function. So this is first function. Cos theta has the differentiation of minus sine theta, that is minus sine theta, plus second function differentiation of first function, that is this is sine square theta. And like here we will use chain rule. So chain rule says that there are lumps of functions. So a lump of function is square, a lump of function is sine theta. So first we have to find the square. So x square, it is first like this for the differentiation. So it will be 2x because 2 minus 1 1, so it will be 2x. So sine square theta will be 2 sine theta, and then we remain by the other lump which is sine theta. Sine's derivative is cos, so we will find it like this in here, that is 2 sine theta cos theta. So now after solving this, L cube pi by 3 minus sine cube theta plus 2 sine theta cos square theta. So we got this, that is f dash x. Now we have to put this equal to 0 to find the value of theta. So I am sure that the value of theta will come tan inverse under 2. So let's find the answer, that is f dash x is equal to 0. So if we put it equal to 0, this everything will come here, divide by 0 and become 0. So we will remain with sine cube theta plus 2 sine theta plus cos theta square 0. And now sine theta will move there, that is 2 sine theta cos square theta. After equal to, the sign will change, that is sine cube theta. And now sine, I will divide these two signs, that is cos square theta is equal to sine cube theta by sine theta. And now this 1 sine theta cancel out the 1 sine theta from these 3 sine theta which are multipliers. And now 2 cos square theta is equal to sine square theta. And now 2 is equal to sine square theta by cos square theta. And we know that tan theta is equal to sine theta by cos theta. And after this, 2 is equal to tan, here is not sine theta or cos theta, here is sine square theta or cos square theta. So the tan theta will become square, and after this tan square theta, and the under root will come into the 2. Tan theta is equal to under root 2, and theta is equal to tan inverse under root 2. So we have got the theta which is in the question. So now we just have to prove that the cone which have the angle tan inverse under root 2 has the maximum value. So we will chunk in tan inverse under root 2 in the volume. So now we will double differentiate it and find that is this maximum volume or not. So this is f dash x and this is theta. So now we will double differentiate this. So f double dash x, again remember that we are differentiating with respect to theta. So L cube pi by 3 will remain in here, that is constant times the function. Now we will solve this. Here I will use chain rule, that is first I will get minus 3 sine square theta, and then the derivative of sine theta which is cos theta, and after this plus 2 sine theta, that is first function differentiation of second function, that is 2 cos theta, and then cos theta again will differentiate because here is also chain rule is applying, that is cos derivative is minus sine theta, and after this plus second function derivative of first function, that is sine theta, and sine's derivative is cos theta. Now after this f double dash x is equal to L cube pi by 3 minus 3 sine square theta cos theta, and this 2, remember that this is also multiplicable by this one also, so that 4, and the minus sign comes outside, that this will become minus 4 sine square theta cos theta plus this 2 will multiply in here, 2 cos cube theta. And now after this, minus minus plus, that is minus 7 sine square theta cos theta plus 2 cos cube theta. Do you remember while solving the question we got the value of sine square theta is equal to 2 cos square theta, so we will chunk in the value of this sine square theta in here. This is just a method of solving this question. It is no hard and fast rule that you will apply same step in this question. This question can be solved in thousands of ways. I am just doing my simplification to solve this question so that we can get all this negative to prove that this is maxima. So L cube pi by 3 minus 7 sine square theta is equal to 2 cos square theta cos theta plus 2 cos cube theta, and after this L cube pi by 3 minus 14 cos cube theta plus 2 cos cube theta, and just simple simplification of this, that is minus 12 cos cube theta and 3 4s are 12, and minus 4 L cube pi cos cube theta, which is less than 0. If we put the value of theta in here, it will automatically come less than 0. So we have solved this, and this is maxima, and we have proved that the semi-vertical angle of cone of maximum volume with given slant height is tan inverse undo 2, and it is of maximum volume. So we have just solved this question. If you don't understand how I solved, watch this again, because this is very important. This is equally important like those box question and inscriptions. Now let's move into the 5th question and the last question of this video. In the next video I will solve the next 10 questions. Okay, so this is our next question. So let's read the question carefully. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 times the volume of sphere. So this is also an inscription type question. I took this question because this question will clear your concept on how to take derivative with respect, because this question is a little tough one, because I also didn't got it the first time, because in this question the derivative with respect to is taken as x not r. I also didn't got it because r will change and x has no role in this question. So what was happening, I also didn't understood this, but now I understand, and I will show this question to you. And if you know this one, there are hundreds and thousands of inscription questions in which students always confuse in which respect we have to take the question. So with this one you can understand everything easily. So let's solve. So first I have to write that h is equal to r plus x. R is the radius of sphere, x is from here to here, and r is the radius of cone, small r and big R, and h is the height of cone. So the height of cone h is equal to r plus x. I wrote this like this. Now what is the volume of cone? That is 1/3 pi r square h. This is the volume of cone. Now h will change, because if the cone squeezes, and this will increase and the height will change. So while changing, r won't change because r is the radius of sphere, but x will change because this will squeeze like this. R won't change because r is the radius of sphere, and sphere is fixed, but the cone will change, so x will change. Also small r will also change because its radius will also increase, but in here radius is already taken, so we don't have any other value which can give us fixed value and a variable value together so that we can solve and find out the answer. So in here r is already given, so the another value which is changing is x. So in here we will differentiate with respect to x. We need the value of r with respect to x. How we will do it? Yes, the famous Pythagoras theorem. That states that the hypotenuse square is equal to base square plus perpendicular square. So now we will solve it. That is r square is equal to r square minus x square. So this is the value of r and the value of h is in here. So now we have got the value of r, which is the radius of the cone, in the form of r square, that is the radius of the sphere, minus x, that is this. So now we have got a variable value and a fixed one, so that we can solve this question. So now let's chunk in the values. 1/3 pi r square is equal to r square minus x square, and h is equal to r plus x. So now we got a function, and now it is clear that we will differentiate with respect to x. So let's differentiate it. This is fx. Now we will differentiate. So that is 1/3 pi. This is constant times the function. And now first function, differentiation of second function is r. The differentiation of constant is equal to 0, so this is 0, and differentiation of x, like d dx of x is 1, so this will 1, so this there no value will come, plus second function, differentiation of first function r square is also a constant, because 1 square will be 1, 2 square will be 4, and these all are constant. So this is 0, minus 2, 1 will be minus from this 2, that is x. So this is the value after this, 1/3 pi r square minus x square plus 2 rx minus 2x square. Now we will solve this further. That is 1/3 pi r square minus x square minus 2rx minus 2x square. Now it is becoming an equation. After differentiating, it's becoming an equation, that is pi, this constant times that is the equation, this r square, and minus plus minus 2rx minus plus, that is 3x square. And now we got this. Now this is the f dash x. So to find the value of x in terms of r, we will put it equal to 0, because we have to find the value of the changing variable in maxima and minima. So put it equal to 0. This all will become 0. After going there, we will get only this. Is equal to 0. So now we can factorize it and find the value of x in the form of r. Now we can factorize this and find the value of x in the form of r. So r square, we need the multiplication of, now we need the multiplication of minus 3r square x square and addition of minus 2rx. We can get this by minus 3rx plus rx minus 3x square is equal to 0. With this, when we will add this, and it will get 2rx, and when we will multiply this will get minus 3r square x square. So now r minus 3x plus x r minus 3x is equal to 0. R plus x is r plus x and r minus 3x. So r is equal to x, or minus 3x is equal to minus r, minus cancel, x is equal to r by 3. So x can't be equal to r, because this doesn't satisfy this diagram. So we have to find that is this x value is maxima of this function or not. So we have to differentiate the function again. So let's differentiate it. So this is the differentiation of that function, and this is the value of x. So now we will find that is this maxima or minima. So to do this, double differentiate this, that is pi by 3 constant times the function, first function derivation of second function, that is r minus 3x plus second function derivative of first function, that is minus 3 in here. So now pi by 3 r minus 3x minus 3r minus 3x, and now this is pi by 3 minus 2r minus 6x. So now let's put the value of r in here, pi by 3 minus 2r minus 6r by 3, value of x from here, and now solve it. 3 2s are 6, that is my pi by 3 minus 4r, that is minus 4 pi r by 3, which is less than 0, hence this is maxima. So now we got the value of x and proved that this is maxima. Now the last step is to find out that this volume is 8 by 27 times the volume of sphere. So let's find out this. So this was the original volume of the cone and this is the value of x. Now we will just chunk in the value of x in here, that is volume is equal to 1/3 pi r square minus x square. Now r square by 3, 3s are 9, and then r by 3 plus r. Now after this 1/3 pi 9 r square minus r square by 9. I'm just taking the LCM, that is 9 r square minus 9, or LCM, that is r plus 3r by 3, and after this 1/3 pi 8 r square over 9 and 4r by 3. After this we will solve this and we have to prove that 8 by 27 times the volume of sphere. So let's take out 8 by 27 out of this and let's see that if the volume of sphere comes or not. So 8 by 27, 9th is a 27. In here what is left, that is pi r square 4r divided by 3. So now it's just looking like the volume of sphere, like 27 4/3 pi r cube. This is the volume of sphere. So we have just proved that it is equal to the volume of sphere multiplied by 8 by 27, and it is the maximum volume. And we also found the value of r with respect to x, and this was almost one of the most difficult question in maxima and minima, and we have just solved it. If you don't understand, watch it again, because if you know how to solve this one, I guarantee that you can solve any question in maxima and minima. So in the next video I will come with the next 5 most important questions on maxima and minima. So if you like the video, please hit the like button and also subscribe to this channel, because I give you help in math, the most difficult subject in this world, in the most easiest way. So please subscribe this channel, and after subscribing please hit the bell icon, because this will give you notification when my new video will come, because my every video will boggle up your mind, will give it exercise, and also you will know what questions are important and what are not. I also give basics, everything about math. You can ask questions in the comment below, and always remember that math is everything.